be able to see my presentation now. So my name is Arnold Janssens, and I will present the approaches of taking thermal bridges into account in the Flemish EPBD regulations. The outline of my presentation is quite simple. I'll first give some background about regulations in Flanders, then show the overview of different approaches and the way they have been adopted by the design and construction practice. I have a short word about compliance procedures and then come to conclusions. First, some background. In the Flemish region in Belgium, the EPBE regulation has been in force since 2006, and based on the EPBE regulation, a number of requirements are set forward for new buildings and for renovated buildings with a building permit. The requirements relate to thermal insulation requirements, to the net energy demand for heating, to the energy performance level, which is a measure for the total primary energy use of the project. There are minimal ventilation requirements and also summer comfort requirements related to an overheating indicator. Now, the requirements indicated in red are requirements that are, or performance indicators that are influenced by the transmission heat loss through building junctions. And so to take the transmission heat loss in building junctions into account, some specific approaches have been developed in the regulatory context. Now, perhaps it's good to have some background about one of the indicators for thermal insulation. So apart from requirements for the maximum U value of the individual building envelope components like roofs or walls, there is also a requirement for the maximum K level of the whole building, which is a measure, the K level is a measure for the mean U value of the building envelope. And as the graph shows you here, this mean U value depends on the volume over heat loss area of the building. The current requirement is the K40 level, which means that buildings with a volume over heat loss area smaller than 1, which is typical for detached small houses, they have to meet a mean U value requirement of a maximum of 0.4 watts per square meter Kelvin. Buildings with a higher volume over heat loss area may have a larger maximum mean U value of the building envelope. Now, the influence of building junctions on the transmission heat loss very much depends on the quality of architectural detailing of the project. And the figure below shows you some results of a calculation study that we performed 10 years ago based on two-dimensional heat loss calculations. And it shows the increasing K level for a number of building typologies, depending on the way the building junctions were detailed. So as you see in the business as usual scenario where thermal bridges are not excluded, the transmission heat loss may increase by 15 or 20% compared to the requirement of the K40 level. When thermal bridges are consistently avoided, the transmission heat loss increase may be reduced below 5% for the K40 requirements still. So the influence of building junctions even increases when buildings are better insulated and have a K level that is lower than the K40 level in the current requirements. So because of the importance, it is also important to make clear or to define clear approaches to take thermal bridges into account. And this has been developed about 5 years ago and has become in force in the regulations since 2011. Now, because of the specific attention to enforcement and compliance in the Flemish regulatory framework. 3 different options have been provided to building practitioners to take thermal bridges into account. And you see them here in the scheme. Either you choose as a designer and as an EPB assessor for option A, which means that you perform a detailed calculation, much in line with what Steven explained earlier. Or you choose for option B, which is a more pragmatic approach. I'll explain it later on. We also call it the method of EPB accepted junctions. In this option, you don't have to perform a detailed calculation for those junctions that comply to some basic rules and are therefore EPB accepted. And in the calculation of the project, then simply a fixed addition of 3 K-level points is added to the total K-level of the project. Even when you follow this approach, you also may have a number of non-EPB accepted junctions, and for these junctions you still have to perform or document in a more detailed way what is the transmission heat loss through these junctions. Finally, you have option C, which is what we call a penalization method. If you as a designer or as an EPB assessor chooses to do no effort to document the transmission heat loss to building junctions, or you do no effort as a designer to eliminate thermal bridges, then you can do this, but then you have to take a fixed addition of 10 K-level points into account, which means that the transmission heat loss is increased by 25% compared to the K-level requirement of K40. And in order to meet this requirement, you then have to do another bigger effort in reducing the transmission heat loss through the building components by adding additional insulation. Now I'll give some more information about the compliance, but it's already good to know that the option that is selected needs to be reported by an EPB assessor based on as-built data. By selecting this option in the EPB software, and the effect of thermal bridges is then taken into account as an addition to the transmission heat loss coefficient by an additional term related to building junctions. Okay, a quick word about the different options. So as I already told you, in option A, a detailed calculation is needed. So for each linear junction, you need a linear thermal transmittance and the length. And for each point-wise junction, you need the point thermal transmittance and the number of point-wise interruptions. You can use numerical calculations for this based on the European standards, or you can use default values, which are also given in the regulation. You see here an example of the table with values, with the default values depending on whether you have a linear junction or a point-wise junction, and depending on whether you have a thermal break in a structural junction or not. So there's a list of conservative values available. Now in option B, as I already explained, the junctions are subdivided into categories. Either you have the EPB accepted junctions. These are junctions without strong thermal bridge effects and which are taken into account at building level by adding a fixed number of K points to the K level of the building. For these junctions, the assessor do not need to report the junction geometry and the linear thermal transmittance. Then you have the non-EPB accepted junctions. These are the thermal bridges in the project that are not solved and that need to be taken into account in the calculation for each building junction, similar to the way option A, the detailed method, is working. Now a word about the EPBE accepted junctions. A junction is EPBE accepted when it fulfills one of three basic rules, pragmatic rules. Rule 1 states that you have an EPBE accepted junction when at the junction the two insulation layers in the two components that are joined in the junction overlap with a minimal contact length. Rule 2 says that you also have an EPBE accepted junction when you have an insulating element inserted in the junction, which ensures the continuity between the insulation layers of the two adjacent components. Or a final rule, Rule 3, says that you have an EPBE accepted junction when the path of minimal thermal resistance, which may still be present in a thermal bridge, is long enough. The path of minimal thermal resistance between the indoor and outdoor environment needs to be longer than 1 meter. So these are three descriptive rules. But apart from that, you may also show that you have an EPBE accepted junction when a calculation shows you that the linear thermal transmittance is low enough, is lower than a certain limiting value. These are descriptive rules, but they are described in a more detailed way in the regulations in order to allow for compliance checks. For instance, for basic rule 1, the minimal contact length is specified both in an equation and graphically, as you see here. So the contact length should at least be the minimum of half of the insulation layer thicknesses, or half of the frame width in the case you have a window wall connection. These performance-based specifications are also included in the regulations for basic rules 2 and 3. Now the descriptive rules mainly aim to stimulate the use of good solutions in design by encouraging continuity of thermal insulation at building junctions, for which you see a number of technologies of thermal breaks in these figures. The descriptive rules also have the advantage that they are easy to apply in design and to check visually. You see here, for instance, two ways of applying basic rule 2, where an insulating element at the left-hand side is inserted at a foundation junction with a cellular glass block supporting the inner masonry leaf, for instance, and connecting the wall insulation layer and the insulating screed in the floor. And at the right-hand side, you see a similar example of the junction of an insulated sloped roof and an insulated cavity wall, where you have continuity of thermal insulation at the connection. That's about the descriptive rules in option B. Apart from the descriptive rules, you may also show compliance by using two-dimensional calculations. And for this purpose, the regulations list a number of limiting values for linear thermal transmittances, which are a function of the geometrical typology and of the technical feasibility. For instance, you see here an overview of a number of categories taken into account in these limiting values. And because of the geometry, limiting values at exterior corners of junctions, for instance at roof eaves, have another value than the limiting values at interior corners. For instance, the roof junction between a flat roof and an upper wall, which has another value, which I failed to say before, but which is clear over here, is that in the Flemish regulations, the linear thermal transmittance calculation is based on exterior dimensions, which is shown in the index over here. Now, this option of showing that your junction complies with EPB accepted junctions is mainly present in the regulations to allow building manufacturer companies to develop product documentation based on this EPB accepted junctions method. And already quite a number of building manufacturing companies have developed their own reporting tools, web-based tools, which give, and here you have an example, which give some building junction atlases that may be used by architects in their design. For instance, here you see an example of the junction between an insulated warm flat roof and an above roof cavity wall, and an example of the eaves of a flat roof. And based on the limiting values, the manufacturers may, for instance, develop specific rules for their products. For instance, here for the roof junction, you see that a lightweight masonry block is used in the inner leaf here. The thermal bridge or the building junction atlas of the manufacturer states then that the thermal conductivity of this block should be lower than 0.22 watts per meter Kelvin in order to meet the limit state value which applies to this type of building junction. So this information may be used by designers and by EPB assessors. This is another example of product documentation that is specifically developed by product manufacturer companies to create information about thermal transmittances, in this case point-wise thermal transmittances, that may be used by EPB assessors in reporting the EPC results. These are examples of steel connections for lintel supports, where depending on the type of lintel support and depending on the type of steel of which the lintel support consists, and of the thickness of the cavity that is crossed by this support, depending on this, the different point thermal transmittances are given in this figure, and they may be used by the designers and EPB assessors. A word on compliance procedures. In general, the assessment in the Flemish region is done, the EPC assessment is done at the moment of completion of the works by an EPB assessor who creates the necessary input in EPB software and uploads these results to a database which is managed by the regional authorities. And in case requirements are not met, the authorities charge the builder with a fine which is proportional to the size and severity of the error. This is in general, so this applies not only to thermal bridge calculations, but to all types of elements that have an effect on the requirements. Now, related to thermal bridges and building junctions, it is the EPB assessor who selects one of the methods to take thermal bridges into account and who collects the necessary information to make the assessment. When thermal transmittance values are needed, they need to be calculated according to the specifications for validated numerical calculations, which are based on the European standard ISO 10211. And in fact, anyone who can demonstrate conformity to these specifications may perform the calculations. For conclusion, we have different approaches to take thermal bridges into account in the regulation. This has been in force since 5 years, and we see that these approaches have increased awareness of good thermal detailing, both in building industry and in design. The effect is clearly visible on construction sites. The use of specific solutions to avoid thermal bridges has clearly increased when you take a look at construction sites. So you see that designers do an effort to follow these descriptive rules which are laid out in the regulations. And finally, the EPBE approach has also stimulated the development of more specific guidelines, web-based tools, for instance, better product documentations by the building industry. So I thank you for your attention.